Welcome to Prerna Gate classes. So today's topic is project management. In this project management topic, we will further discuss about the two main techniques which are used to construct the network using the given data for any project. And the two techniques, especially we'll discuss today, is the critical path method and project evaluation review technique. That is, one is CPM and another one is PERT. In short form, it is PERT PERT, that is program evaluation and review technique. So these two things we'll try to discuss in depth such that they are useful for the preparation of this gate examination. So here, as we see, the main the project management topic, it is having very vast history. So this was started after the Second World War. In the main techniques, so which we are going to study today, that is the critical path method and the project evaluation review technique. These two techniques are the most important techniques which are used for the project management and also in order to estimate the project duration. So let us see what is meant by a network, or what is meant by project, and what are the related terms in the project management. And later on we will discuss about and we will also try to solve the examples on this particular topic. Okay. So first of all, what is meant by a project? So a project is a set of interrelated activities which comprises of certain duration and which also consume certain resources. So there is a specific objective or output for the project, and it has to be achieved in a particular specified period of time. So now a project is simply a particular, simply a collection of activities, and these activities, especially, they are in the form of certain relationships. So these relationships should be understood properly in order to construct the network as per the given data in the project. So here, the two most important techniques which are used for this project management are the program evaluation and review technique and the critical path method, which is CPM. So there are many other techniques which are available for network analysis, but these two are the most important techniques which can be applied very frequently and which can be which can be used efficiently for estimating the project duration. So here, let us see what are the main differences between program evaluation and review technique and also the critical path method. So first of all, the PERT technique, it is a probabilistic type of dealing the problem. That means in PERT we'll try to assume the time estimates which are based on certain probability theories. From these probability theories, so we can try to estimate the overall project duration for a particular specified project. So therefore, the PERT technique is in general assumed to be probabilistic in nature. So PERT technique is generally it is assumed where the project is uh, carried over for the first time. That is, it is especially applied for the projects which are being carried out for the first time. That means, so it is for non-repetitive type of activities. So in that case, in the non-repetitive type of activities, so as there is no past data available, so we cannot estimate the exact time or the time duration for each and every activity and also for overall project duration. So here what we use is we use the probability techniques or the probability theories in order to estimate the project deadlines or the project durations. So this program evaluation review technique generally it assumes three time estimates. The three time estimates are the most likely time, optimistic time, and pessimistic time. And coming to the critical path method, whereas this critical path method, it is uh, generally based on the earlier data, the data which is already present in the past. That data is considered for the activity durations, and these activity durations are considered and based on that data. Once the network is constructed, then we'll try to analyze or find the total expected time duration for the complete project. So here in critical path method, as the time is known or the time is considered from a repetitive type of activities, so it is certain in nature. That means whatever the time durations which are considered for each and every activity in the critical path method, that is considered to be deterministic in nature. These time durations which are considered to be deterministic, so they do not tend to change with respect to time. And also other difference between this critical path method and the program evaluation and review technique is the critical path method, it is a event oriented technique. Critical path method, uh, excuse me, critical path method actually it is a activity oriented method, not a event oriented. Whereas the program evaluation and review technique, it is an event oriented technique. That is, we will further see about what the activities or what are the events are and what are the various terminologies which are involved in this project management. So we'll try to analyze or we'll try to study or understand this network diagram using a small basic example. Now, in this particular example, so you can see the basic definition for a network. So, first of all, let us understand what is meant by a network. So, a network is a graphical diagram consisting of a configuration of arrows and nodes for showing the logical sequence of various tasks to be performed to achieve the project objective. So that means a network is, in simple terms, can be defined as a representation, a graphical representation, which involves the arrows and nodes which are representing the activities and events, and also they will clearly represent the procedural sequence, a proper sequence of the tasks which are involved in a particular project that are to be accomplished. So now if you observe this example, in this particular image, you can see a circle starting with a number represented by 1. So in general, in this project management, so the circles are generally used to represent the events. So the events are sometimes called as nodes, and these nodes are numbered as per the activities and as per the development or as per the relation of preceding and successor activities. So here, this particular node, so that is the first node. The first node represents the starting point of the whole project. The node 1, it simply represents the uh, event which is simply the starting of the complete project. Another aspect is here each and every project it should start with a unique node. That means every project should start with only one event and it should also end with one event. So there should not be any two or more events which represent the starting or ending of a particular network diagram. So here, if you observe the first node, it is connected to the second node. That is the second circle, where the second circle is connected to third, and further it is connected to fifth, and so on. So if you observe this particular arrow, the arrow represents the activity. So there are mainly two types of representations which can be used for this construction of the network. So the construction of network, we have two basic methods which are activity on arrow and another one is activity on node. In these two methods, um, generally the activity on arrow, AOA, so activity on arrow, that type of method is most popularly used for constructing the network using given data. So here the activities are generally represented by arrows and the events are represented by the nodes or circles. So first of all, if you come to know what is meant by event, an event simply represents a particular time, a particular point of time uh, in the say duration of the project. That is a milestone. That is after completing a particular activity, so you can represent that particular uh, position with the help of a event, and this event is generally represented with a circle, and it is also called as node. And these nodes are connected in such a way that they they are in the arrangement of as per the logical sequence of the tasks which are to be performed in the project duration. So here, this particular example is based on the activity on arrow method, and also here we observe this second node, node 2. So this node 2 is also called as the event 2. So this event 2 is the ending point of the activity 1, where the activity 1 is simply the formalized specifications, whereas the one represented in this circle, that is in the node, that represents the event 1. And for each and every activity there should be a proper starting node and ending node. That is, for each and every activity there should be a starting point, that is a starting event should be properly represented, and also proper ending event also should be represented. So here, if we see this example, in this particular example, the complete network construction, it is done based on certain rules, and these rules are generally called as Fulkerson rules. Fulkerson rules. These Fulkerson rules are mainly used to represent or to construct a network based on the project data. The Fulkerson rules say that each and every activity should be represented only once in the complete project. So that means every activity which is represented in the project should be appearing only once, and it should not be repeated anywhere else. That is one of the most important rules. And another thing is, so for each and every activity, so there should be clear starting point and clear ending point. That means there should be a tail event and a head event which is represented for each and every activity. And also the direction of these arrows, they have no significance. They simply show the direction of, say, the development, and the length of the arrow is also of no importance, because the length of arrow, it is simply represented in order to make the project network in a concise manner. So that means in order to represent the graphical way in a most clear or proper representation. So here, this complete network diagram, it starts with, say, the a unique node which is called as the event, and the complete project duration should also end with a unique node which is called as the ending node. And also for each and every activity there should be a starting node and ending node. So now let us see an example for this project network, or the project management. So here we'll try to, excuse me. Okay, here you observe here there are certain things which need to be clearly understood before starting the uh, actual construction of a network. So we'll go through one by one. So first of all, we'll see about the program evaluation and review technique. So here we observe this program evaluation review technique. This technique is generally applied for non-repetitive type of projects which are being undertaken for the first time, and it also involves certain probability, and these probability theories are applied for uh, uh, finding out the total project duration. So, in critical path method, the time estimates are assumed to be known with certainty. That means the time durations for each and every activity, they are known very well and they do not tend to change. But this project evaluation and review technique, which is also known as the PERT, is for such a projects which involve certain probability. Probability involvement is there because these are the first kind of projects which are to be being started. So one cannot judge or estimate the exact duration of each and every activity involved in the project. So for that purpose, we generally try to estimate, assume three time estimates. So the three time estimates are basically considered with the help of a beta distribution. So based on the beta distribution, the three time estimates which are known as the optimistic time TO, and the most likely time TM, and pessimistic time TP. So optimistic time is the shortest time taken to complete the activity, which also means that if everything goes well, then there is more chance of completing the activities within this time. That means if all the resources and equipment and the other things which are needed for the particular activity are available at, uh, at particular time, and we are going to complete that activity before the expected time, then such type of time estimate is considered to be optimistic time, that is TO. And whereas most likely time, it is the time taken at the normal pace for completing a activity. So that type of time estimate is considered to be most likely time. And coming to the pessimistic time, so it is the longest time that an activity would take to complete, and it is also considered that it is the worst time estimate that an activity would take if unexpected problems are faced. That means if there are any delays due to unavoidable circumstances, then there may be a long time for certain activities. So considering those delays also into account, when you try to estimate the time, that type of time estimate is simply known as pessimistic time estimate. So for this, but we also need certain expressions. So the for calculating the average time, that is the mean time, and also for calculating the variance, especially the variance is needed for the activities which are involved in the critical path, such that we can try to estimate the probability of completing the particular project and its duration. Okay, then the expressions which are used for this purpose, that is in project management, the most important say expression or formula which can be used is average or mean time PA, and this mean time is nothing but the value of the activity, and it is also given by TO plus 4TM plus TP by 6. So here the TO is nothing but the optimistic time, and 4TM represents the most likely time. That most likely time is considered 4 times, and optimistic time and the pessimistic time TP are considered a single time, and whole divided by 6, it simply gives the average or a mean of the particular time estimate. And also in order to make sure that we are calculating the variance, we can use this expression, which is sigma square is equal to Tp minus To by 6 whole power 2, that is whole square. So here the variance is calculated in order to determine the probability for the activities or the probability of whole project duration based on the different activities which are lying in the critical path. So another important expression which can be used is probability for project duration. So that is the probability of completing the project within the scheduled time or contracted time may be obtained by using the standard normal deviation. That is standard normal deviate where the T is expected or T is the expected time of project completion. So generally TS represents the scheduled time and TE represents the estimated uh, normal deviate. I mean the TE is simply the expected time of project completion. So here the probability Z can be obtained by using the expression TS minus TE by root of sigma sigma square. So in this variance is calculated only for the critical path activities, and you can also find the probability. So the probability of completing the project within the scheduled time it is P of T, that is the P of T less than Ts is equal to P of Z. So this is actually obtained from the normal distribution tables because the probability is generally based on the assumption of the normal distribution curve. So probability is in general in this particular per technique we'll use the normal distribution for estimating the probability. So coming to this example. So let us see an example problem for the PERT. So in PERT, so here the given example is says that an R&D project has a list of tasks to be performed and whose time estimates are given in the following table. Now, if you observe this table, there are different activities. Say like activity Ij. Ij is representing say like 1, 2, 1, 3, 1, 4, so on. So here in this first activity that is 1, 2, the 1 represents the starting node and 2 represents the ending node. That is 1 is here assumed to be tail node and 2 is the head node. So therefore, we can assume that I is equal to 1 for the first activity and j is equal to 2 for the same first activity. Similarly, the second activity, the I is equal to 1 and j equal to 3 and so on. We assume the ij's. So based on the I and j, we can try to find also the earliest times as in the case of say critical path method also. So in this particular example, the activity names are clearly listed, say like A, B, C, D, E, and so on, up to J, and the optimistic time, the most likely time, and pessimistic time. These three time estimates are given, and based on those data, we'll try to calculate uh, the probability. We'll calculate the probability. Before that, we need to calculate the variance, and we need to draw the project network. Unless until we try to draw the project network accurately, it is difficult to obtain or difficult to calculate the probability. And once the critical path is found out, so the activities which are lying on the critical path, those activities variance, the sum of the critical activities variance is considered in the uh, say calculating the duration of the project. So here in the given problem, so the another important aspect here is to find the probability that the project is completed in 90 days, and if the probability is less than 20%, find the probability of completing it in 24 days. So let us try to solve this problem. So here, first of all, we need to observe the various activities and how they are related with each other. That is the logical relationship. So the activity 1 2. So the activity 1 2 is having the tail event. The tail event has 1, and also the second activity 1 3. It is also having the tail event as 1, and also for the third activity the tail event is 1. So simultaneously we have to start three activities, so which can be further carried on with the next number of activities. So first of all, let's try to represent this node 1. So node 1 is represented with a circle, which is an event, and simultaneously the three activities can be represented in the following manner. So let us see the network diagram. So if you see this network diagram, so here from 1 to 2, we have started representing an activity which is the 1 2 activity, and 1 2 3. 1 2 3 is another activity which is also simultaneously or concurrently uh, started along with 1 2, and 1 4 is also another activity. So these three activities, that is 1 2, 1 3, and 1 4. These three activities have to be drawn first in the order. That is, once while starting the construction of the network, so we have to consider the events and also the activities in a logical sequence. The first given activities are these three, and for these three, as the node is 1, as the tail node or the starting node is 1, so these three will have the same tail node, that is 1 2 activity, 1 4 activity, and 1 3 activity will have the tail node as the same, which is equal to 1. And then we have also the other activities. So the other activities, namely 2 4 3 4, has to be represented after drawing the 1 to 2, 1 to 3, and 1 to 4. So this 2 4, that means 2 4 activity can be started only after completing the 1 to 2 activity. So if you see this particular diagram, this 2 4 activity, this is the 2 4 activity, and this 2 4 activity can only be started unless this 1 2 activity is completed, because there is a logical sequence of relation between all these activities. And also another activity which is 3 4. So 3 4 activity, it can be started only after completing the 1 4 activity. So therefore, this 1 4 activity, once it is completed, then we will go to the 3 4 activity. So similarly, we will draw the other activities which are say like 3 4, 3 5, 4 6, and so on. The activity 3 5 can be started in the construction of the network, so unless the activity 1 3 is completed. So unless the 1 3 activity is completed, we can represent the 1 5 activity, and this 3 5 activity, 3 5 activity is having a duration of 8. So 8, so it may be in terms of days. So generally it is given in terms of days, that is 8 days. And finally, we'll complete the network construction or the diagram by establishing as per the given data. So as we have another activity which has to be represented for 4 6, so we'll take another arrow and we'll try to represent this 4 6 activity. And there is another activity which is 6 7, and also 4 7 and 5 7 are the other activities which will be at the end of the network. So here this 7 node is a unique node, which is also called as the ending node of the whole project. So in this way, the project network construction has to be done. And once the project network has been done, so we'll try to calculate the earliest time and the latest time. So here, the earliest time and latest times are generally used for finding out the amount of time that can be delayed in each and every activity, such that the total project duration is not delayed, but For each activity, what is the amount of time that can be delayed, and also try to use this earliest and latest times for finding the critical path. So critical path is another important aspect in this construction of a network diagram. So in order to find the critical path, one has to follow the path which is longest in nature. So that means we are considering the path say like 1 to 2, 2 to 4, 4 to 6 and 6 to 8. We need to add up or sum up all the activity durations which are lying in this path. So that is one way of calculating the paths and its durations. So the wherever we find the longest path in the complete project network, that path is considered to be the critical path. So here, so while evaluating all the different paths, we can come to a conclusion that the activity 1 to 4, 4 to 6 and 6 to 7, it is having the longest duration. That is 1 to 4. 1 to 4 we have a duration of 9 days, and 4 to 6. 4 to 6 we have a duration of 5 days. So 9 plus 5 we have 14, and from 6 to 7. 6 to 7 we have a duration of 8. So, so 14 plus 8 we have a total duration of 22. So this is the highest project duration which can be obtained only in this particular path. So we can determine that this particular path, which is 1 4 4 6 and 6 7, this 1 4 4 6 6 7 is now considered to be the critical path, and the total duration of project is 22 days. So in this manner, one can construct the project network diagram. So coming to the probability. So the probability, so it can be calculated based on the given expression, that is z equals to ts minus te by root of root over the sum of the variance, which is lying in the critical path or the critical path activities. So here the ts is the scheduled time and te the expected time duration. So therefore, in the given problem, the given data is say in such a way that the scheduled time is 19 and the expected time which we have determined from the project network, that is 22. So therefore, 19 minus 22 upon the root of 2.77 plus 0.444 plus 1.777. These three are the variances of the activities which are lying in the critical path. So that can be calculated using the formula which is known as sigma square equal to t naught square by t naught square minus t m square by 4 whole square. That is the calculation part that we can see here. So the variance which can be calculated using this particular expression, which is sigma square equal to Tp minus T naught by 6 whole square. Here the expression is Tp. So Tp represents the pessimistic time, whereas To represents the optimistic time. And for each and every activity, we are going to calculate this variance. This variance for the critical paths that can be considered for calculating the probability duration. So by substituting all the values in this particular expression, we will get a value of say like minus 1.3416, and based on the normal distribution tables of this minus 1.346, we can arrive to the final probability, which is occurring to be 9.01%, and therefore the probability of completing this particular R&D project is simply 19 days. That means within the 90 days is 9.01% only.